Hello and welcome to Wise Feline Influence Maps. This plugin allows you to take special decision making, like where are the enemies, where are my fellow allies, where are the places which there are some allies but not too many, but there are some enemies to kill, so I go there. The sample contains two scenes, a simple one, a complex one. The complex one is more fun to look at. This blue base is attracted to our position, but only if there are not enemies around. The yellow ones try to cover it and defend it against the enemies. And the red ones are the enemies, which try to get close, but where there are that many yellows, they will get scared off. I will show you how did I make the blueprints, basically, and we will create a sample integrating utility AI to it as well, so you can see that. So as you can see, this will come to me, and but will come to me only if there are not enemies around. It will not come to enemies exactly. Like as you can see, it stops there because there are enemies, and then when these basically scare the enemies off, it comes to me. So if I go where basically mostly there are enemies, it will be far away from me until they scare the enemies, and then it will come to me like a good boy. Uh, let's look at the simpler scene, however, first. So the simpler one is similar. There are only red ones, which are the enemies, and the yellow ones, which are the citizens. They do not give a damn about me, but the red ones try to go close to yellow ones. If they are so close, they will go scare off and go back. And the yellow ones simply try to be far away from enemies. If they come close, they will go somewhere else. So they just do not like each other, but the red ones try to go toward the yellow ones and then scare off, but the yellow ones in general just try to avoid the red ones, like it's like a plague or something. Uh, the influence map itself is an actor. You can either directly add the C++ class to your scene, which is not recommended, or create a blueprint. Here, actually, I added the C++ one for these. It will ask you what its name is. The name of this one is citizens, and we put our citizens on, and it has a width of 60 cells, a height of 60 cells, and each cell is 50 centimeters, so half a meter. So we cover an area of 30 meters by 30 meters, and the position of the map object actually matters on like where is the origin of the map, is the position of the map on X and Y, but not Z. And then we have another map, which is the one for enemies. We call that one main, the same size in the same place. The debug colors are important when you enable gameplay debugger or visual logger support that we have, which I'm going to show you in a second. But how do agents use these maps? Basically, an agent which wants to use a map but add its influence to a map should have a WF influencer agent component. If you search here for influence, you'll see it. And it only asks for the map name, which map you want this agent to put its influence on, and also a template, which is like the shape of the influence of that agent. The template has only two parameters: how many cells its radius is, in this case is 10, and what is the value of the cell basically in the radius. So here we have a radius of 10 pixels, and the like 0 time of the curve is where basically the enemy is, and 1 is where at the edge of 10 cells, basically at the edge of the circle. So until half of the way, like 50%, 0.5, the value of the cell is 1 where that enemy is, but at the edge is 0, and here like it's the fall off. When we look at the map, it will be obvious. So let me see. And you can turn on and off visual logger for the enemies and the characters. Let's turn the citizens is off already. The enemies is on. The higher values will be red and the lower ones will be white. So as you can see, near the enemies it's red, and then the other, and it's more obvious in the visual logger. If I open it by entering vislog here, and or if I went to tools menu and start recording, it will record everything, blah blah blah, and then if I choose something, let's disable the other categories. This one is us, we want that. And then we go up, it shows you basically where in the map is red, and these are like the blue spheres are the actual enemies, and you can see it in time as well. This is the citizens map. And as you can see, in the places which are blue spheres, you see more yellow greenish colors. This is the enemies. And yeah, as you can see in the edges, the values fall off, and we also write the values as text as well, so you can see them. And where there are many enemies concentrated, like here, the values are even like bigger than the places which there are not that many enemies. Here, because there are like two at the same time, you can see that the values are even higher, like near to 1. It's possible to have even values bigger than 1 because these add their influence. But let's see how do these basically read the maps and search the maps. So if I open citizens, which is the simplest, they simply in their tick check if their AI controller is valid or not, and also they check if the map basically which they want, which is main, which is the map of the enemies, basically search it for values less than 7. You could search for greater than 0.7, sorry. And if they find something which is greater than 0.7, they are going to sorry, let me redo that. So we have a delay once in a while. Our tick component executes, and what it does is that it says, okay, we do a delay of 1 second, and after that we see if our air controller is valid or not. And if our air controller was valid, then we check where basically we get the map of main, and check the value, like if there is something greater than 0.7 in our close by, like radius of 5 cells. As you can see, we could change this greater than to other operators, and we could change also 0.7 by, for example, if you make it 0.5, it will get scared faster. Then the search returns a boolean which says if it found something, and if it did, this return value then will contain that. And if that happens, we basically move to the position to a position which is like less full of enemies and is more sparse by searching for values less than 0.8 in our 60 meters. If we want to move to somewhere sparse, we can make it like 0.4. So we'll search for something 0.4 and radius less than 0.4, and radius of 60 means that it will search the whole map. And then if we find somewhere which is not full, we will move to that. As you can see, we are using the return value of the search. This version of search gets the positions and also returns them in invoke position, but there is a version which does the same in map positions. In map coordinates, basically integers which start from like where the maps are, which is here, is 0, 0, and it will move positively to the right and to top. The enemies are similar. They try to get the highest value, basically. When their map is valid and also the tick is valid, they try to get the highest value around themselves. And then when they find the highest value, like nearby in radius of 10, they will move to it. This doesn't have a bool of success because there will be something which has the highest value, and after they do that, they move to it. But it's not the whole story. Like there is another which is searches for values less than 0.5 is basically fleeing in a radius of 10, and then move to that. We can, if we want them to flee more, we can increase this. Uh, how does the enemy choose if it should go to which one of these, basically this one or that one? As you can see, there is a branch here. The one at the top goes to the highest value nearby. The one at the bottom goes to a value relatively low. How does it choose? If the current position of the enemy, get basically cell value at the actual location, is something less than 0.5, then it will be brave and it will go close by to some high value. But if it's higher than 0.5, so there's some citizens around, because the map used here is the citizens map, uh, it will simply try to basically flee. We don't need this, so let's delete it. And the map, as said, like, and to get the map, you basically get our subsystem, WF Influence Map subsystem. You just get that in Blueprint. Just say get WF Influence. It will. No. You get the subsystem, and then you can get a map by name from it, which we are doing here. And the name of the map is here is citizens. If you wanted to look at another map, then we could do that. Let's just take a look for fun, because we told the citizens to be more like try to go further away from enemies when they want to go. We allowed them to go more further away. So as you can see, sometimes there is just a citizen alone somewhere, and these all had delays because these are expensive operations. The more complex map, however, so basically all of the things that they like search on the map has delays, as you saw here. You could use timers as well, also in C++, of course. Uh, Also, the influencer agents put their influence like with a delay, which you can choose. For example, this one is the attractor, which you saw in the first demo. This will put its influence on the map, which is called attractors, and the delay is chosen here. It does it like 4 times a second, each 0.25. The template is different because like the radius is smaller, but the curve is much more aggressive, basically, uh, and up to like 70% of the radius it stores one and then goes towards zero. It could be anything. It could be like close to me. It's not good. So if we wanted to basically make it like uh, if we wanted the yellow ones to go to, let's say, somewhere around this but not on it, we could change the curve. So where this puts its value, uh, let me, okay, 0 point, let's say 0.3, okay, add a key here, and then here, now it will be like the influence of the blue thing. Close to it is low, in the middle is high, and further away is low as well. So if we play this, oh, we are still in the other map. Save everything that we did. The yellow ones should be now a bit more distance from. Oh, weird that they do not do that. Let's give it some time. Okay, now they do. So because the enemies are not here, they will not get close. But if the enemies are close, they will get close. So let's go somewhere which there are no enemies. If there are not enemies, they'll not get as close as before, and I can like make it even further away by increasing the radius and making the curve to return one only, like, because these are low radius numbers. Let's do that. Just increase the template of the base object basically from 7 to radius of 15. And also let's okay with a shape like this. Let's just move this to okay, it almost has zero influence close by now. So now yeah, okay, now it is more like what I wanted, which is like be somewhere close to this, but not too close. But if there are enemies there, be there. And how we achieve that, that's the main thing of the other sample. So first let's look at the shape of this. It will be cool. In just a few frames, good enough. The curve shape of the base should be very interesting to you. As you can see, we write the name of the map here so you can see what map you're looking at. This is citizens, this is the main map, which is the enemies. This is the defense which we calculate and I'm going to talk to you about. And this is the attractor map. And as you can hopefully see, let's see. But it's not showing the one that I want. Now it shows the one that I want. You can see it actually in the calculated map as well. So let's see it on that one. Okay, now the bug is gone. It was like Unreal, not us. Let's do. Sometimes the visual logger needs some disabling and enabling to work. And this seems to be one of those instances. This is not on us. Okay, so let's. Okay, as you can see, where the object was, it's white, but further away from it, it's like darker blue because of that curve shape. Yeah, the smaller sphere is where the object actually was, and as you can see close to it is like mostly white. And then let's get rid of the perspective. Yeah, and then further away it's like more blue because of the curve shape. Now, how do these behave? The base one is pretty simple. It just looks at where the player is. Basically, it has a delay just like the others. It the difference is that gets the enemy's map, which is the main one. It searches for values, but not in its position, and instead it gets the player controller and it gets its pawn and that location, which is us basically. So searches around us for values less than 0.5. If we wanted to make more like scareful, fearful, we can make this 0.2. So it will only come to us if we are really empty. And we can increase the radius so it can like be more free. Then it will move to. That's not interesting. The defenders aren't that interesting either. They look at the defense map, they are not that different, I mean. And then they will find somewhere, like search for the highest value in their 20-meter radius, and they will go to. But how it's like that they choose good values, that all relies on the defense map. So basically, to do a defense map, we inherited a blueprint from influence maps. So I created like here, I said okay, blueprint, and then as you can see, I can inherit from influence maps here. Uh, What do I do inside? I create this map from other maps. How do I do that? We have multiple maps. we have a map of enemies, which I get here after the my AI controller, my map connections are valid. Basically, what I do is that I created map variables for maps. So it's main map, attractor map, citizens map, and delay map. These are all of type like influence map actor. If the variable is null, one of them, then I set all of the variables from that branch. I just get the map, which is the main map, and then set with the main map variable, then the next one, and the next one, and the next. After I have all of the maps, attractor and series and main, this branch will like say that okay, the map is valid. So the true will be this will be true basically. And then we do a bit of delay, which we have in the variable for this for map calculations, and that's public. What we do is that we normalize the enemy's map, so we do not care that if there is one enemy somewhere or five, we want to consider a value as one at most. Normalize basically brings the values to a range of 0 and 1, even if there are 10 enemies somewhere and the value there is like 7.2, that will become 1 and smaller values will be like moved. So everything like the ratio is the same, but the difference is between 0.1. The minimum is 0, the maximum is 1. Then I add the map of attractors with a strength of 3. So I multiply attractors by 3. And then uh, attractors map multiplied by 3, like somewhere if the value is 1, it will be 3. If it's 0.5, it will be 1.5. If it's like 0.8, it will be 2.4. And then I will add that to the normalized enemies map, and then I subtract the citizens from it. So where there are citizens, there will be less influence, so they will not be on top of each other. So if there is some other citizen there, basically I will not be going there. But if there are not other citizens somewhere, if like the enemy value and the attractor value is the same, it will have a higher value because then like what subtracted from it is 0. And then I normalize the result so it can be easily used. That will create the map which you saw. Basically, if I do this again, I hope that it doesn't. I know you'll say a lot. And if you look at one single specific frame, there is a map of like enemies, where the enemies are. There is a map, like enemies are here at this frame. Most of them are in the middle here. And citizens are very close, as you can see, to the left bottom of them, where we are. And then there is the attractor, which is like close to the citizens. And then the result of those will be in this map, which you can see here. Because there were citizens, it will be like where there are citizens, it's more close to white. Where they are not, it's more black. So if you can see, like, because here there are citizens and they are subtracted, they will be like, okay. And this is the result of those formulas. So you can easily do combine and multiply, and let me do every slog, and then at the end do something that like the citizens and the enemies are in a place which it will be hard to do that with this setup because the citizens are like most of the time close to enemies but not close to the base. So let's change the curve for the base again, so its value is like 1 when it's close. Don't need this key anymore. Okay, now it should be much more possible to do what I want, so they are close to the base and not close to the enemies. This is still coming to me and those are coming to it. But because the influence is high, like I need to reduce the, let me, like if I reduce the radius of the base attractor, they will come closer to it because values further away will not have high value. Oh, now that's good. Okay. I want to have a situation where the enemies and like should be good enough. I wanted somewhere where enemies and like citizens were not so much close to each other. Let's see if we got that or not. I guess we got it because as you can see there are lots of white where the citizens are. So let's see. That's the blue one. We changed the curve so the shape is changed. That's where citizens are too. So citizens will be minus and enemies will be added. And because we are like subtracting these, this is like these places are white because the citizens are here. So if there was another citizen, would it choose these places? We would go instead at this place, which is good. Uh, so yeah, if we increase the number of citizens, that would happen, and the delays are too low at the moment. So let's see how you create these templates, by the way, and the curves. Basically, to create a curve or a template for an influencer agent, what you do is that you go to miscellaneous, and for the curve, you just choose curve. It's normal Unreal curves with the docs if you don't know about them. But the templates are a data asset. You search for influence map template, and then you name it something, and then here you choose the radius and the curve, and that will be it. And then you can use this in an like influencer agent component in your blueprints. Let's delete it to not clog the project, but here then you could use it in like here to choose what template you want for this agent and with what delay. I hope you enjoyed it and I hope you can use it. Also, we support the Insights profiler. I'm going to show that in another video later on, and I hope you have fun making your game.